Last Monday of the semester for this class. Final exam next Wednesday, 10:30. Be here on time. I know class normally starts at 11, but finals week is different. So be here at 11. Be here at 10:30. Don't be here at 11. All right. So let's continue on with what we were talking about last class. We were talking about delta G. What was the main thing about delta G, Bailey? What did delta G teach us? So what does delta G tell us if it's positive? Remember? Delta G is positive means what? Jaden, you remember? Why? Mervais. What does delta G is positive mean? Not spontaneous. Very good. So what does delta G is negative tell us? Spontaneous. Very good. So have we learned a bunch of ways to calculate delta G? Yes, we have. We learned that delta G equals, we can figure out delta G if we know the delta G of the products minus the delta G of the reactants, right? This is similar to heats of formation that we learned about. We can calculate delta G of formation of the reaction using the formula delta G equals delta H minus T delta S. How do we know which one we should be using? Any thoughts, Angelina? How do you know which delta G to solve for? Using this equation, using the equation delta G equals summation of products minus delta G of reactants. Remember that one? Just depends on what you're given, basically, right? So if you're given all the information for delta H, temperatures, and delta S, use this equation. If I give you a bunch of delta G's of formation, and it's a table of products and reactants, add up all the products, subtract all the reactants. There was one more method for learning delta H. So we did all of this in chapter 6 in Gen Chem. We learned how to find delta H using a formula, which was delta H equaled P delta V or something like that. I can't remember what it was. We used the heats of formation, and we used Hess's law. Everyone remember Hess's law? What was Hess's law? Hess's law was taking multiple reactions, adding them together, and whatever the delta H's reactants and products added up to after we subtracted out the things that showed up on both sides, that gave us the delta H of the reaction. So we can use that same relationship with delta G's. So if we have a bunch of delta G's with given delta G value, or if we have a bunch of equations with given delta G values, if we can manipulate those equations in such a way by reversing them, multiplying them by some factor, adding them all together, then whatever you're left with, that new reaction would be the sum of the delta G's. So if we don't remember Hess's law, let's have a couple other reviews. So if a reaction can be expressed as a series of reactions, the sum of the delta G values of each of those individual reactions is equal to the delta G of the total reaction. Okay? Pretty straightforward, right? If a reaction is reversed, then the sign of the value of delta G simply reverses. A reaction that is spontaneous in one direction is unspontaneous in the other direction, right? If the amount of material is multiplied by a factor, the value of delta G is also multiplied by that factor. So the value of delta G is an extensive property. So let's go ahead and do a quick problem. Okay. Everyone remember how to do this? So this is a third way to find delta G, maybe even a fourth way, actually. So this is a fourth version of finding delta G. What would you do first, Jack, looking at this problem? Explain to me how you would figure it out. So we have these three equations. Everybody see that? We want to get to this equation, okay? So what we're gonna have to do is we're gonna have to manipulate the three equations on the bottom in such a way that when you add them together, they equal the reaction on the top. Is that easier said than done? Or is it just easier done than done? Just do it, okay? So it looks a little confusing, right? There's two reactants and one product. So what I do is I take this in steps. Is this the only, so in this version on the top here, we have a C3H8 as our product. Do we see C3H8 anywhere else in those three reactions on the bottom? You see them anywhere? So what does that tell us, Bryce? Huh? That the first equation is going to be used, and we have to get it to where the C3H8 is on the product side. Everybody see that? So you see how I highlight C3H8 in the product of what we want overall, and then I find the only source of C3H8 anywhere in these three reactions. So when we add these together, if we want the C3H8 to be a product, what we'll have to do is do what, Kayla? What do you think, Nate? Anybody know? We got 3 classes left. We're going to finish chapter 17 today. We're going to dabble into chapter 18. We're not going to learn chapter 18. Yeah, Kaylee. Very good. Since the C3H8 is in the products and in the reaction we're looking at, C3H8 is a reactant, the only way we'll ever get this C3H8 to be a product is by flipping the reaction. So we flip the reaction, we take the products and we put them as the reactants. We take the reactants and we put them as products. As Kaylee said, it was negative 27074 kilojoules of negative delta G. Since we flipped it, it becomes positive 2074 kilojoules. Everybody comfortable with that? Okay. Step 2. What are we gonna look at next? So this is the only source of carbon anywhere. So this is the only carbon. And notice that there's no carbons in here. There's no carbons in here. Therefore, this carbon is the only source of carbon. And if we want it to eventually be the same as the reactant, what do we need to do, Emma? Cade, what do we do? Is it on the right side that we want it to be on? It is. So we do not need to flip it. Does everybody see that? Is it the right number of carbon molecules that we want in our product? How many do we want? So what should we do? So we're going to multiply this whole reaction. I'm going to erase all this. This whole thing is going to get times by 3. So, oops, did it twice. We take this reaction, we times it by 3, and we get 3 C's plus 3 O2s makes 3 CO2s. Oops, that's not a 3. Makes 3 CO2s. And then since we multiplied the reaction by 3, we times the whole equation by, or the delta G by 3. The new delta G is negative 1183 kilojoules. Everybody comfortable with this? So once again, you might be like, what about all these oxygens and all these carbon dioxides? How am I going to make sure that those cancel? What do we say about that, Riley? Who gives a what? Anything, right? You don't give a crap about the stuff that you don't have to worry about. If the problem I gave you is correct and you're doing your manipulations correct, all of these carbon dioxides and oxygens will end up canceling each other out, okay? So don't even worry about it. So we've now looked at, and once again, you're going to add all these things up, but right now we've reverse this one. We've times this one by 3. So we've looked at C3H8. We've looked at C. Let's now look at H2. So how many H2s are over here right now? 2. How many do we want to have? So what should we do? Times that whole, is it on the right side? It is a reactant. We want it as a reactant. So we multiply that whole reaction by 2, which multiplies the delta G by 2 to get to negative 914.2. Now, if you're a risk taker, you can assume that everything is correct. And all you have to do at this point is add up this plus this plus this. And as long as everything canceled, you're good. If you want to be steady and double check your work, since you are doing a final exam and the final exam has no chance for corrections, no chance for. So for the final, assume that it is a Scantron. Okay. I might make it where you don't need to do a Scantron because I have to give partial credit anyway. It's not that much more work for me to go through and manually circle all the things, and then I look at it a little bit more. But assume that it's a Scantron and bring it. And worst case, you can always not bring that not use that Scantron. Okay. Sorry if that was expensive for you, but you can go walk around and sell it for probably triple the price during finals week. If you want to make some money, go get a bunch of Scantrons and find the classes where they're big classes and they use Scantrons and sell them for, how much are Scantrons? $1 a piece or more? Less? Oh, that's kind of a ripoff. Sorry, I make you owe. Luckily, the third test I didn't make you. So you've paid a whole $1.58 this semester of what you've needed. I'm sure you could go places and get one, but you could also be a connoisseur and go sell Scantrons to people who need them for $2 a piece, and you would make a racket. You'd be like, but who would forget a Scantron? Oh, imagine how many people forget Scantrons in this class, right? So people do it, or just be nice and give them away and let that karma come back to you in the long run, right? Maybe it'll help you with the test. You could just add these 3 values, but what you should do is you should add up all the reactions after you manipulate them. Look at the things that canceled. CO2 canceled, 4 waters canceled, 2 plus 3 oxygens canceled. These 5 oxygens, all we're left with is 3 carbons, 4 hydrogens, and one propane. Is that what we wanted? Yes, it is. So all we did was add up these 3 things over here. That gives us negative 23 kilojoules. What does that tell us, Bronson? Is this reaction spontaneous? Try again. Correct. Why? Because it's negative, okay? When you get a negative delta G, it is spontaneous. Mervais, what's up? Well, let me tell you this. I am not wrong. This is directly out of a textbook, edition number like 7. So unless 7 editions and all 7 million people who have looked at this think it's wrong, but go ahead and finish your thing. What are you talking about? So does everyone understand what we did? We flipped this negative. We switched it around, right? We times this by 3. We times this by 2. When we flip it around, this is what we get. When we times out all of those things by 3, that's what we get when we times all of those by 2. All you do is you add up everything on, so you make a little arrow. Everything on the left side of the arrow, you add up. But if something, like there's 3 CO2s here and there's 3 CO2s on the right, those are basically reactive intermediates. We looked at those this semester, right? If something is formed and then it is used, it is no longer there. So we don't have to put it in the balance equation. So what are you saying is wrong about this? What first 2? Because if you only use the first 2, you're not going to have any hydrogen, and you need 4 hydrogens in your product. Remember, we said that this is the only source of propane. This is the only source of carbon. And if we don't use the third reaction, we have no hydrogen. And can we create propane with just carbon? Can carbon just spontaneously poof into hydrogen? Well, there's a radioactivity, and in like 75 million radioactive steps, it could do it, but that's not going to happen in this daily reaction of the synthesis of propane. Okay. So if you're not sure how to do this, what do you think will make you get better at it? Kayla? Or practicing your homework, okay? Oh, you want to know what's better? Go on the internet and look up a video and watch it 25 times, not well, and just confuse yourself, and then tell me how the video that I didn't make sucks. And I'll be like, yeah, no crap. That's why I didn't make it, okay? Watch my videos and pay attention and write notes while you're doing it. And guess what? It will probably work out okay. But everybody has their own style. No, I'm a visual learner. I just watch and I learn everything. That's not the way the world works, okay? You need to learn to take notes. Even though when you were in your school and you did it, you could just like get by listening and getting through. You're in college now. Classes get harder. You actually have to practice them. That's why we have homework. The homework is not some way for me to just be like, ooh, you know what's going to be fun? Making students do homework out of their normal time. Instead of them getting to play video games and watch 5-second videos over and over and over again till they notice they've seen it 20 times, that they're going to have to go do some homework. You think that's what I get off on, making people do homework? Is that why we do homework, Ray? Why do we do homework? To practice. Very good. So if you're not sure how to do this, practice it. Why do we learn all this stuff? Anybody tell me that? I mean, really, why do we learn all this stuff? Like, do we really need to know how much a weak acid is going to dissociate 10 years down the line? You think so, Riley? No, you don't. You'll never probably need it. But those steps of doing it are going to help you to learn things later on. So if this is your last chemistry class, then probably most of this stuff doesn't matter, okay? But for everybody else who's going to continue on more chemistry, this is going to come on. Alejandra, does this stuff ever come into play later on? Only a lot. Remember I told you I never took Gen Chem in college? Worst mistake of my life. Did I get through it? Am I still up here teaching as a PhD? Yes. Would my life have been easier had I taken Gen Chem and listened? Probably a lot, okay? Probably I wouldn't be teaching here. Probably you'd be seeing me accepting a Nobel. I'm just kidding. But in general, right, the stuff you learn at the beginning helps you overall on the end. You might not think that, but all these little steps are going to be important later on, okay? So why is this important? If you were trying to do a reaction that is not spontaneous, you're not going to be able to. So let's say you're trying to like start a company, okay? Say you want to make a company, right? Say you want to make some kind of pharmaceutical or drug or some kind of gadget. If you want to make that thing and it is a non-spontaneous reaction, does that mean you cannot do that reaction? No, that means that you can force that reaction. So look at this. Water breaking down into hydrogen and oxygen, that is a non-spontaneous process. But if you link that with the carbon monoxide addition to oxygen to make carbon dioxide, when you add these two reactions, this non-spontaneous with this spontaneous, we get an overall spontaneous reaction, and something that wasn't going to happen on its own is now happening on its own by combining it. Do you see that? So this gives us the opportunity to think about how can we make this better, right? So when you do something like, it doesn't have to be in college, it can be in life, when you're looking for a house, when you're looking for anything, when you're trying to do any kind of decision, you have to research it and think about it. And if you've done it a couple times, don't you think the fourth time is going to be easier to figure it out than if you're just doing it for the first time? You think like when you're getting married, could anybody just plan their own wedding? Yes, they could. Why do they hire a wedding planner? Because that person does it for a living and knows all the little tricks and things to make it easier. Can you do it on your own? For sure. If you have been married 4 times, would your 5th marriage be a little bit easier and maybe a little more economical? You're like, oh, maybe I shouldn't put down the deposit because this is my 5th marriage, and maybe in 2 months when we're planning it, things like that. But in general, the more we do this, the easier it gets for us, and that's why we do it, okay? So what you can see here is glucose reacting with oxygen. to make, anybody know what the name of that reaction's called? Taking glucose, reacting with oxygen to make carbon dioxide and water. It also produces energy. Is that a spontaneous or non-spontaneous based on that negative 2880? Spontaneous, right? So do we spontaneously convert sugars? So how do we get energy? This is like, I want to say respiration, but maybe that's not the word. Maybe the Krebs cycle. I don't know, not a big biochemist. Okay, so I wouldn't know. But in general, that's how our body makes things happen that maybe wouldn't want to be spontaneous is you do a combination. Okay. Why do they call it free energy? What's free about the word free energy? Free energy just tells us the maximum amount of energy released from a system that is available to do work to the surrounding. For many exothermic reactions, some of the heat released due to the enthalpy change goes into increasing the entropy of the surroundings. So it's not available to do work. So the free energy lets us know how much is actually available for that reaction. And even if some of this free energy is generally lost to heating up the surroundings, what can happen is we can take an unfavorable reaction and make it favorable. Delta G is less than delta H because some of the released heat and energy is lost to increase the entropy of the surroundings. This is just saying that in real reactions, even though we say it's reversible, it's not truly reversible because every time we flow electricity through a wire or through anything, you're always losing a little bit, right? There's always a little. So in a perfect world, if I was to roll a ball along the floor, that ball should theoretically roll forever. But there is some resistance from the air. So there's air resistance. There's a little bit of friction from that ball rolling on the ground. Do we all agree that there's a little tiny heat trail if you were to slide something on the ground? If you had heat vision, you could see the path that object traveled. So even though we put that energy in, you're always losing a little bit of energy. So even though the free energy dictates that something should be spontaneous, it not always is. So really all I want you to know for this is how to calculate delta G for these things. This last section of chapter 17 is called delta G and its relation to the equilibrium constant. There's an equation. You might need to do it on the homework. Feel free to skip this part. This is not going to be on the final exam. So I'm not going to relate K or Q with delta G on the final. It might be on the homework. The homework has all the solutions posted. If you want to just copy that and not learn anything, feel free to just copy that and get a whole 0.01% of your grade better on the homework just to not do well on the final, okay? You could always copy the homework, and I have no problem with that. Hopefully you're getting something when you're copying the homework. When you copy the homework, at least make sure you're understanding it. So doing the homework and having someone help you is better than not doing it at all. Okay. Copying the homework from the answer key is still better than not doing it at all because at least you know what is the sign of the answer should be. What should I get when I'm trying to solve for something? And that will help you with the final exam. In lab this week, we're meeting for lab. You will be checking out of your lockers in lab, and then you will be getting last fall's final exam. If you want to do it in class, you can do it in class. The teacher should be able to help you. I told them if the person's come out and check out and leave, give them 10 out of 10. That's on you if you want to know how to do it, okay? All of your lab professors should be able to help you with that final exam. Your final exam will be semi-similar. I'm going to probably maybe not have as much old stuff or make it more multiple choice kind of old stuff. But in general, if I was taking an exam in roughly 1 week and 2 days, I would know how to do everything on that worksheet that we have for lab this week. Everybody understand that? So you have to show up for lab. If you don't check out a lab, you're going to get charged like $40 to your student account fees because you signed the paper at the beginning saying you would check in and check out. you need to go to lab this week to check in or check out. If you can't make it, make sure you contact your lab professor. Make sure you bring your key. There's also a fee for a lost key, so bring that key in this week. Now I'm going to show you this equation. What's the difference between delta G naught and delta G? Can anybody tell me? One is under standard conditions, meaning what are standard conditions? 25 degrees Celsius, everything kind of in its normal state. Okay. So we can calculate that using the equation delta G naught equals summation of N delta G naught reactants or no products minus summation N delta G naught. And this is N of reactants, and this is N of products. N just telling us how many there are, and you do it times the reactants, okay? So this is just taking the values, adding up all the reactants, adding up all the products, subtracting all the reactants, okay? Now, if we know delta G, whether it should be spontaneous or not, we can look at RT that comes from the gas law times the natural log of Q. What was Q? Anybody remember what Q was? Any thoughts on this? Huh? The reaction quotient, and what did that mean, Robert? It is not a constant. This is, so do we all know what K is? What is K? Capital K. That's the equilibrium constant, and that's the ratio of the products over the reactants raised to the power of the coefficients, right? Remember solving for K? Q is just taking those values at non-equilibrium conditions. So remember how we made an ice table and I gave you values and then you plugged it into an ice table and you did minus X plus X to figure out what was changing and stuff like that to get to K? Q was at non-equilibrium conditions. So if Q is at equilibrium, then that means delta G is equal to 0, right? The reaction is not going to go spontaneously one way or the other. It is exactly at the perfect thing where it's making the exact amount of products as it is the exact amount of reactants. That's why Q is equal to K at equilibrium, okay? So for these equations, if Q is less than 1, that means the reaction is going to want to stay as reactants. When Q is equal to 1, I don't even know what this means. Let's see. So for basically what you need to know is you could plug in these values and just see if a reaction gets more or less negative, more or less spontaneous at a given temperature. Like I said, we're going to skip all of this stuff. This would be a problem using the Q. Is this reaction more or less spontaneous under conditions than standard reactions? So this was finding it at, what's this one? So this one was solving for, so this would be like, so like I said, I don't think we're going to do this. This is too much review from before. But if you wanted to learn how to do it, if you're going to become a thermodynamicist, then you could look at all of the values of either the pressures or the concentrations, solve for Q, plug it into this equation, and then see, did that value get more or less negative? That is kind of the point of this, but I would like to skip that stuff because it's not going to be on the final, and I don't see any of us in here being hardcore thermodynamicists. And if we are, you'll learn that during hardcore thermodynamics, which is PChem. Okay. Anybody in here chem majors? Raise your hand if you're a chem major. Hooray. You will get to get a sticker at the end that says honk if you pass PChem, because when everyone says OChem's the hardest class in college, really it's PChem. Okay. The only reason people say OChem's harder is because not many people take PChem. And I'm sure like the hardest like engineering class is super hard, and the hardest like super analytical math class is super hard, but like classes that people take, people usually say OChem's the hardest, but that's just because there's so many pre-med people who take it and then no longer become pre-med after that class. I'm not going to say why, since I teach that class. So I obviously don't think it's that difficult, but I also see the way some people do it, and I see why some people can think it's difficult. Okay, let's do one last conceptual question before we move on to chapter 18. According to Le Chatelier's principle, what was Le Chatelier's principle, honey? Remember? That is something that I do plan on putting on the final exam because I like it and it's pretty straightforward. What was it, Kayla? Very good. So Le Chatelier's principle was saying if you add to one side, it pushes the equilibrium the other way. You take away from one side, it pulls the equilibrium towards that direction. There's also some temperature and some pressure things that you have to think about, but those can all be thought about with adding and subtracting also. So according to Le Chatelier's principle, the dependence of free energy on reactant and product concentration, which statement is true? I hate these questions. I'm not going to put on the test. We're skipping it. Okay. We're done with chapter 17 at this point. There's a bunch of equations you can use that can help you. You can just really look and see what's given to you to decide what you have to do. But in general, we've learned all the different ways to solve for delta G, right? You're not going to have to use Q or K in any of the problems on the final. Let's look at electrochemistry because it is fun. Okay. We had a electrochemistry type lab last week. So remember we had a redox titration reaction, right? And if we looked at that reaction, so in that reaction, it was a redox reaction and it was a long fancy reaction that had like 6 irons react with 1 permanganate. And then that reaction was broken down into 2 half reactions. We're now going to learn how to calculate that half reaction thing, okay? So I think for the class, let me see what I have on Canvas. For this class, oh, anybody see I started grading the exams? I graded 40 of the 90. I'll finish the rest today, so you will get your score soon. For chapter 17, when is chapter 17 homework due? May 13th. When the heck is that? Next week? Day before the final. Chapter 18 homework due the day after the final. It's worth 1 point, so if you don't do it, you only lose 1 point. But if you do it, I'll give you up to 5 points, so you get 4 points extra credit. Oh my gosh, 4 points extra credit. I'm going to do this homework so hard, but I'm going to get a 0 out of 10 on all the other homeworks because it's not extra credit. Does that make any sense in the world? So if you take those 4 points extra credit and you add it to that 0 out of 10 you got an F on that other thing. Just spend the time doing your normal homework assignments, okay? So I know extra credit makes us all giddy inside and we're like, yay, it's free points. It's 4 points. Do all of the things. Every semester in this class, I have at least 5 people who do all of their homework after the final. And I'm like, cool, now you have time. But guess what would have been nice? Doing all of that work before the final and using it to help you understand how to do the final, okay? So, how much time do we have to the final? Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, Monday, Tuesday, Wednesday. 9 days. You have 9 days to study. You can spread out the studying. Or you could be like, when's the final again? Next Wednesday? Next Tuesday night, I'm going to go hard. I'm going to go so hard. I'm going to drink like 18 Red Bulls and I'm going to stay up all night. And then when it comes time to the test, I'm going to sleep through the test. Is that a good philosophy for cramming? Have I crammed for some finals in my life? Yes, I did. And actually, I did good on it, but it was PChem, that gnarly class, and I stayed up all night. That's the only time I've ever stayed up all through the night studying for a test. And it sucked the next day, okay? Luckily, it was my only final that semester. But in general, spread that studying out over a week, and then you feel good the day of the final. If you have any other finals, you can still go take care of other things, okay? So this homework set, if you submit it, oh, look at that. You have the solutions to it. So let's learn how to do this. It is for extra credit. Let me see if I have the final exam review that I'm giving you today. So there's a question on buffers. There's a question on initial rates. There is which of these would have a positive entropy? That's new stuff. Titration problem. We ever had a titration problem ever? Some of us have. Le Chatelier's principle. That's going to be on the final, the practice worksheet. Here is calculating delta S, then calculating delta G, and then is the reaction spontaneous or not? So you're going to use delta S, you're going to use delta H. This one probably has delta G equals delta H minus T delta S. So you see how I have you figure this out? How do we know which one we'd use on this one? We look and see which values are given. So based on this, Jessica, which version of delta S are we going to solve for? Which formula? If I give you all these delta or these S naught values, you know which one it is? Anybody know? Well, looks like we got some time to figure that out. Great. You will get to do this in lab. Is the reaction spontaneous or not? At what temperature would you find it spontaneous or non-spontaneous to spontaneous? How would we figure that out? Anybody know that one? Set delta G to 0. Very good. There's some multiple choice stuff. So you can see here, this is the kind of test I might give you. These ones you have to do by hand. These multiple choice, you still show your answers. You circle the work. You might not need the Scantron. I'll probably just do it because I don't want to have the answers be correct or wrong. So you can just circle the right answer in these cases over here, okay? Notice that I have an extra credit, balance the redox equation in acidic aqueous media. So this is chapter 18. I put that as the extra credit for the final exam. Let's go ahead and learn how to do that right now, okay? But before we go to learn how to do that, so you might not be able to do this. So if you have lab either today or Tuesday, then maybe we won't have learned how to do this. You can ask your lab professor, or you can wait till Wednesday and do that problem later, okay? But we will learn that on Wednesday. Let's talk about why do we even care about electrochemistry? Who can tell me why we care about electrochemistry? Loot? We don't. We do a little bit, right? Okay, let me ask you, is there anybody in here who in the last 3 days has used in one form or another a battery? Yes or no? Anybody? Who has not used a battery in the last 3 days? Anybody? Hold your cell phone up and show me with your cell phones who has not used a battery. You have, right? You've all used a cell phone in the battery, right? How many of you in here have seen Breaking Bad? Anybody? I don't want to ruin it, but is there ever a time where they run out of electricity in the middle of the desert? And what does whatever that dude's name is have to do? He builds a battery. So, is this important? Only if you're going to be making meth in the middle of the desert and running out your battery. But maybe you're not making meth. Maybe you're just out camping and you accidentally leave your door open, right? And you just happen to have a bunch of chemicals. Well, let me tell you a little secret, okay? It was great that, what was his name? Walter White. It was great that he knew exactly which direction to make the things work for the battery to flow. But what we're going to learn is if he connected it the wrong way and it didn't work after an hour, switch it and it'll work, okay? Have we not learned about if it's not spontaneous in one direction, it's spontaneous in the other direction? Yes or no? Have we learned that? So at least if we have that concept down, if you are trying to figure out how to put batteries into a remote control and it's not working, what's the other thing you can do before you start freaking out and throwing the remote control at the wall? Flip them, right? Maybe you read the plus side wrong, and even though you're never wrong, all of you are always right. Anything that you got wrong was my fault for not teaching it perfectly. I'm sorry about that, okay? And let me apologize for all of the things you get wrong on the final since I didn't teach it so amazingly. But you can always just turn that battery around and then maybe it'll work. And then if it doesn't, maybe the battery's dead, right? But in general, if you just got a new battery, you put it in the remote, odds are it should work. If it doesn't work, flip it around. So the goal of scientific research is to understand nature. Once we understand the nature of something, we can then use it efficiently, right? Being efficient makes it more important We could look at, the world and be like, oh, why don't we just do this? Why don't we just do that? Well, a lot of the things we're doing in this world are being done to think about the future, right? Does it matter if we burn gas to make electricity for the next 50 years? Not really. There hasn't been any big differences in climate or anything like that, right? Recently, that's just the everyday hustle and bustle of the world getting hotter and colder. It doesn't have anything to do with the carbon dioxide levels being 4 times the highest they've ever been at any other time in the history of the earth. I'm sure it's not that, right? How could we explain that by science? I'm being sarcastic when I say this, right? So we are realizing there are some. Did anybody notice that we're a little past spring break, and today was the first spring day since spring break, basically, right? Like, has it been pretty cold recently? Now we finally have a nice day, and now everybody's here. Is that a correlation to how the class is? Everybody's like, ooh, sun's out, go to class. I don't know. That's weird. I've never seen so many people in this class. Thank you for coming. It's not too late to start learning for the final, okay? Because not only is this final count for more points than every other exam, if you beat any of your other exam scores, I will replace that exam score with your final exam grade. So this is basically like a 40 to 50% final if you want it to be. If you had a bunch of good grades and you blow it, it is not worth 40 or 50%. So don't let that freak you out, but just let it know that this test can really increase your grade huge amounts, okay? The average US household currently consumes 1,000 kilowatt hours of electricity per month. That's pretty relative. I guess it does say US. If you go to Sri Lanka, it's probably like 50 kilowatt hours of electricity per month, right? My buddy lives out there and he's telling me how they don't have hot water. They just shut off their electricity for 2 days at a time. We have all these like things that we are like entitled about living in America. Like, can you believe PG&E shut off the electricity for 2 whole hours? I wanted to watch TV those 2 hours. Can you believe that? There's places in the world where they just shut it off for seriously 3 days at a time every 3 days. And that's because they don't have enough electricity to power the whole nation and things like that. But, that sucks that we couldn't get on the internet for that hour and a half, right? Um, Almost all of this electricity is generated at a remote power plant by either the combustion of fossil fuels or nuclear fission. These are kind of old slides. Nowadays, we have renewable solar panels are starting to take over. We have things like wind energy, geothermal, but in general, it's mostly fossil fuels. Many reactions involve the transfer of electrons. So, how does electricity work? It's just the movement of electrons, right? When you think about electricity, if you think about how you can get electrocuted, if you were to stick a metal fork into the electric outlet, could you get electrocuted? Yes. What if that fork is insulated with some rubber? Can you get electrocuted? I mean, I would say no, but I wouldn't try it. Okay. Don't go trying to stick things in there and be like, wait a minute, this said it wouldn't electrocute me. Let me do it, right? So we all know not to stick stuff in the electric outlet, right? Everybody kind of feel yes on that thing. Okay. When you are having kids or watching kids, they do not know that, okay? My daughter's best friend came to school with wrapped up because she stuck a bobby pin in, and I talked to the parents and they're like, you know what, bro? It was my second kid and we just forgot to tell her, and that's the truth, right? With your first kid, like, and that's why we do things, right? You do anything once, you're learning. After you do it, you learn from your mistakes. Well, second kids didn't learn from their first kid's mistakes. So when you're babysitting, make sure you don't let kids do stuff because for some reason, what is entropy? Disorder. There's anywhere in this whole room that the kids could stick in a bobby pin. Guess where they're going to want to stick it? The worst place possible, right? So always be careful and pay attention to that. So things like these are starting to be more common, right? Electric cars are very common now. Having battery storage and things like that. All of these involve the transfer of electrons. So redox reactions are going to be very important. The flow of electrons is associated with electricity. That's why we talk about electrolyte solutions and non-electrolyte solutions, right? Technically, water does not conduct electricity. You could be in a pool of water and stick some power cables in there, and it should not electrocute you. But don't do that because deionized water will not conduct electricity. Tap water will conduct electricity. Once you step into that water, there's probably going to be some ions from the oils and dirt on your body that dissolve in there. So even though it's technically shouldn't conduct electricity, all water usually has ions dissolved in it unless we specifically choose that. So that's why we make the blanket statement, keep electrics away from water, right? If you watch like back in the day, like cartoons and stuff like that, that's how people used to like die, is they were listening to their radio and it fell in the bathtub, and that's how they get electrocuted, right? That's also why when you're in a pool and there's a lightning storm, you get out. If you're in the ocean and there's a lightning storm, you get out. Even though water doesn't conduct electricity, pools have dissolved ions. The ocean has dissolved salts and things like that. So that's why it's always very dangerous, okay? Basic research into the nature of this relationship is going to show us that we can store energy in batteries. So the way to understand how these works is we're going to learn about oxidation reduction reactions. You should have learned this in 115A. Those of you at Professor Perry, did you learn redox reactions? Everybody know how to identify what's the oxidizer and what's the reducer? Yes? So if this is my reaction, what is losing electrons? What's gaining electrons? Any thoughts on this, Molly? So we have sodium becoming sodium plus. If you go from neutral to +1, are you losing electrons or gaining electrons? If you go from neutral, equal number of protons and electrons, to positive, you're losing electrons. Everybody agree with that? Sodium goes from 0 to +1. To go from 0 to +1, you must have lost an electron. So what was the acronym or the onomatopoeia if you're from Hawaii and you don't know how to say English words the right way? What was the acronym to remember that losing electrons was what? I don't use that one, but yeah, oil rig does work. Is that what Perry uses? He would use oil rig. Okay, let me show you why the other one that I like is more. Anybody know the other one? Yeah. Ooh, no, I never heard that one, but that's a pretty cool one. Okay, we're gonna learn it right now, okay? Losing electrons is oxidation. Gaining, no, that's not the thing, okay? I'm just writing it out. Okay. So just memorize exactly what it is, and then you should know it, and you'll be perfect. Gaining electrons is reduction, okay? With oil rig, it was oxidation is loss, reduction is gain, okay? Loss of what? Gain of what? Are we losing positives? I don't like this one because you're not really knowing. Lose electron oxidation. So we say Leo, the lion says grr. So everybody say that together. 1, 2, 3. Leo, the lion says grr. Now you say it without me saying it. Why is that one I like more? Because it tells you losing electrons is oxidation. Gaining electrons is reduction. So did the sodium lose an electron? Yes or no? So what is it, Nana? Is the sodium getting oxidized or reduced? Because it's Lur and not Leo. Was losing electrons is oxidation, Leo. So it is getting oxidized. Okay. The sodium's getting oxidized. The chlorine is going from neutral 0 to -1. Is it gaining electrons or losing electrons? What do we think, Abby? It is gaining electrons. So it is getting reduced. Okay. So we will continue with this on Wednesday. Like I said, we will take these two reactions, We'll split them into what's called half reactions. And then if we look at them, there's going to be an unevenness in the number of negative and positive charges. So we're going to have to add things like electrons, protons, and water to get it all balanced. We will continue on this on Wednesday. It's on the homework for extra credit. It'll be on the final for extra credit. I don't think we'll have any redox reactions. Have a wonderful time. See you all on Wednesday. I will grade your exam by. So there's a couple people who didn't turn in their exam. Make sure you do it. You're going to lose some points, but you'll still get some points.